We live in an age of deep understanding about our universe. From asteroids within the solar system to galaxies at the edge of space, we've seen glimpses of the cosmos our ancestors would have found hard to believe. And a great many of these glimpses owe to one observatory in particular, a telescope which has, for more than 30 years, continuously transformed our understanding of cosmology, the magnificent Hubble Space Telescope. Hubble has provided us with some of our most iconic and breathtaking portraits of the universe, making more than 1.5 million observations over 3 decades of service. And in today's episode, we will use these observations as we relive some of the telescope's grandest achievements, from imaging the most beautiful nearby nebulae to revealing the secrets of a universe at large. These are some of Hubble's greatest discoveries. The Hubble telescope is a bus-sized satellite, which launched into space aboard the Space Shuttle Discovery in 1990. Rising high above Earth's atmosphere, it is able to study our universe in crystal-clear resolution, unhampered by atmospheric disturbances and absorption which constrain the potential of ground-based telescopes. Hubble resides in a low Earth orbit and faces outwards towards space, studying the universe predominantly in the visible and ultraviolet wavelengths, but various upgrades over the years have broadened this capacity to the near-infrared. As mentioned, Hubble has taken more than 1.5 million observations of the cosmos, for more than 12,000 scientific endeavors, its findings being cited in more than 20,000 peer-reviewed papers, some of them yielding the most important information we have about our universe. Hubble has seen generations of stars birthing and dying in spectacular supernovae. It has seen the ghostly emissions of the universe's earliest galaxies, grinding out the first stars at breakneck speed. And it has seen the universe expanding at what appears to be an accelerating rate, with seismic implications on its ultimate fate. As such, the Hubble telescope has single-handedly defined its own era in astrophysics, an era that now overlaps with that of its successor, the James Webb Telescope. But with such a long, rich history of revolutionary research, it's easy to view Hubble's time in the sky as one long, unceasing success. However, this is far from the reality. In fact, the telescope has had to overcome a number of hurdles during its service, many of which arose in its early years of operation. Remember all those long, painstaking delays to the James Webb Telescope, holding it back year after year? Well, the caution shown by scientists was not without reason. Because even the slightest, tiniest fault in an optical instrument can fundamentally impair its ability to make observations. And this is exactly what happened with the Hubble telescope in its early years. A month after launching, Hubble switched on and became operational, and initially, test photographs of its first light did show an improvement on the images produced by ground-based observatories. However, within a year, NASA had announced that the initial images being received from the telescope were blurrier than expected, with stars cloaked by fuzzy halos of skewed light, making clear, precise detail difficult to resolve. An internal investigation traced the problem all the way back to the development of the telescope's spherical, 2.4-meter primary mirror. Unbeknownst to its engineers at the time, the mirror's curvature was marginally off, with a spherical aberration of about 2 microns. While this deviation equated to only about a 50th of the width of a human hair, the mirror was left unbalanced and improperly calibrated for the optical instruments using its light, particularly the wide-field planetary camera, intended to be Hubble's workhorse camera unit. With such fine margins impairing the observatory to such a degree, you can see why scientists were keen to take their time to make sure they got the James Webb Telescope right. The Webb telescope's position in an orbital zone trailing the Earth makes it effectively impossible to reach the telescope for repairs now it has been deployed. However, the Hubble telescope's low Earth orbit did place it within reach of humanity, and thus, NASA scrambled to assemble a servicing mission aimed at salvaging their flailing vision for a pioneering space-based observatory. In the meantime, however, despite the shortcomings of the optical instruments, Hubble remained an unrivaled tool for cataloging and measuring the distances to the brightest extragalactic stars. Cepheid variable stars are volatile stars that pulsate radially on periodic timescales, causing them to vary in size and luminosity on a well-defined basis that can be used as a cosmic benchmark for constraining the distance. This was the same technique used by Mount Wilson astronomer Edwin Hubble, who used Cepheid variable stars to prove beyond reasonable doubt that the so-called Andromeda Nebula was actually an independent spiral galaxy lying at least 1 million light-years beyond the Milky Way. And in mid-1993, Hubble's namesake telescope used this method to precisely measure the distance of another nearby spiral galaxy, Messier 81. Previously, scientists couldn't agree on whether this galaxy was 4 million light-years away or 18 million, as no reliable method could yield precise results. But the Hubble telescope was able to identify Cepheid variable stars in M81, accurately measuring its distance to be somewhere in the region of 11 million light-years from Earth. And in doing so, scientists took a major step towards determining the age of the universe. In fact, it was Edwin Hubble himself who demonstrated that a linear relationship exists between a galaxy's distance and the speed at which it appears to be moving away from the Earth. This recession is due to the universe's expansion pushing galaxies apart, and thus, if we know how far a galaxy is from Earth precisely, we can compare that to how fast it appears to be receding, to accurately constrain an estimate for the Hubble constant, which the telescope found to be around 73 kilometers per second per megaparsec. And finally, armed with their first precise estimate, scientists were able to extrapolate this expansion backwards, to a point where they could go no further, deriving an estimate for the age of the universe as around 13.5 billion years. This placed a firm marker in the sand amid an ongoing debate over whether the universe was 10 or 20 billion years old, and this precise age of 13.8 billion years is a figure that has been rigorously reaffirmed by independent experiments ever since. As 1993 drew to a close, NASA finally embarked on their first servicing mission to Hubble, as astronauts aboard the Space Shuttle Endeavour visited the telescope in orbit to deliver and install replacement components. While not feasible to replace the flawed primary mirror itself, the shuttle crew were able to swap the internal optical instruments, with updated versions implementing their own corrective optics, the same way glasses would be used to correct the vision of a long-sighted person. In space, the shuttle crew had to gently open Hubble and remove its large internal instruments, with the subtlety and delicacy of handling a sleeping baby.